Hello everyone. In the previous video, we discussed the approach to the problem search in a rotated sorted array. We discussed the entire algorithm, wrote down every step of the problem and its approach, and we performed dry run on a certain example, and we did so successfully. We were able to find our answer. So before we start coding this problem, I highly recommend that you go watch that video so that you understand what we're going to implement in this one. And once you've watched that, you're welcome to join me back here where I start the process by defining the lower bound and the upper bound of our search range to solve the first step of our problem, which is to find the pivot element. Let's just write that down. Step 1 is find the pivot element. All right, so we start by giving value to our variable that is low and the other variable that is high. These define the lower bound and upper bound of our search range, as I just said. Then we start a loop over here. So while low is less than high, we check if the value at the midpoint, which will be low plus high divided by 2. And one thing to keep in mind is that this will be a floor value, because in JavaScript we will get a floating point response. So we have math.floor of the midpoint, which will be here. If this value at the middle point, if it is less than what we have at the end of our search range, this implies that we've discussed this already. Pivot is in first half or it is at midpoint. All right, if that is the case, we have to reduce the upper bound to the first half and the midpoint inclusive. So high becomes mid, low stays as it is. So now you will search from the lower point to the middle point. All right, that will be our search range. The pivot will be somewhere over there. But if that is not the case, we know that the pivot will be then in the second half. So we turn low into mid plus 1. And we can have a small optimization over here. We can say that if the middle element happens to be the target at any given point, let's just return it from here itself. Let's not wait for step 2 and step 3 to find our answer. Let's just return it. So once this loop is over, it would imply that low has become equal to high. That is our pivot element. We've already gone through this, right? We defined that over here. Low is equal to high is equal to pivot at the very end of the first step. So pivot, let's just keep it as low. All right. So now we have to perform step 2, that is reduce our search range. How do we do it? We start the process by redefining our low and high. Low starts from 0, high starts from the end. So now we check if the element at the midpoint, at the pivot, if it is equal to our target, we simply return pivot as our answer. If it is not pivot, then we discuss the cases, right? That then either the answer will be found after the pivot or before the pivot, which will be two separate sorted arrays if you look at them carefully. So we have to decide which sorted array do we have to perform binary search on. So we have this over here, and the condition will be if our pivot element, if it is less than the target, and if the target is less than the element at the very end of our search range, that would imply that the target is in the second half, in the second sorted array, as we just saw. We don't have to return anything. We have to change our lower point to pivot plus 1. But if that is not the case, we simply put an else condition and say that, okay, then if this is not the case, if target is not between the pivot element and the last element, it has to be before the pivot element, right? So the upper bound will be restricted to before the pivot element, that is pivot minus 1. So we've successfully reduced our search range. Now we have only one of the arrays to process and we will perform binary search on it. How to perform binary search, which is going to be our step 3 now. We start by defining our low and high, which is already actually taken care of. We simply start off by defining our loop. So the loop, as we discussed, was low is less than equal to high. And if the middle element, which we will define now, this middle element is low plus high divided by 2, and since it is in JavaScript, it has to be the floor value. I already explained this in the binary search solution video, why we need this in JavaScript. So now that we have our middle value, if the element at the midpoint is equal to the target, we simply return the middle element. So the index of the middle element. If that is not the case, if this middle element happens to be less than the target, then we have to reduce our search range to the very end of our process of our search range. But the starting of our search range will now become anything that is after the middle element, right? Because this middle is less than the target. So anything less than the middle element is not considered to be a valid solution for us. So we change low to mid plus 1. Otherwise, we know that if our target is less than the element at the middle position, then anything in the second half of our search range does not count. You have to search for the first half. The first half is stops at mid minus 1. All right, that's what we do. And if we still don't find our answer, we simply return minus 1. So I think that should be sufficient. Let's try to submit this. The basic cases have passed. Let's submit it completely and see how well are we doing. Okay, so there is one wrong answer. And that is because we missed a small equal to over here. What that did was that this was a case where this particular condition should have hit, but what ended up happening was that we ignored the case where the target could be the last element. You see this over here, right? The target is 3, which is the last element. And because you put a less than over here instead of less than equal to, this case was ignored. So now that we know that to be the case, let's submit this once again. And our solution has been accepted, and it's a pretty good solution. 0 ms doesn't get better than that. So we have that over here. That is the solution for search in rotated sorted array. So stay tuned for more such questions and a lot more engineering concepts, and I'll see you in the next one.